So our target market is islands that are burning diesel to generate electricity. That's very expensive. They're paying 30, 40, 50 cents a kilowatt hour for electricity, compared to in the US anywhere from 7 cents in Oregon, which is a great deal, by the way, to 12 or maybe 15 cents in California or New York or other places. And so we think our system, because it is very transportable, also works in lower wave regimes. Lower wave, we don't need the big waves like you have here in Oregon. We can operate effectively in 3-foot, 4-foot waves, 5-foot waves is kind of our sweet spot. And so our system, everyone has their own estimate of what their costs are, and I'll throw out our number. We think we can, our cost of putting in a system is in the order of 8 cents a kilowatt hour. Now that does not include a return on investment and many of the other overhead costs, but that would be the direct cost of generating electricity using our system. That doesn't allow us to be competitive here in Oregon because, as I mentioned, you have Columbia River hydropower at a very favorable 7 cents a kilowatt hour. But it makes us a very good solution for these islands and remote coastal regions that are in the 30 to 50 cents a kilowatt hour range. So we hope to replace diesel. Diesel's twice as polluting. You have to ship it in and then you burn it, so you get the pollution from operating the ship, which is very polluting, as well as burning the diesel. So double savings on the environment there. And I mentioned the components of the system. There's the buoy, which is about 10 feet diameter on the top surface. The pump on the deck back behind me here is a piston and a cylinder. On the wave up slope, it compresses, generates the pressurized seawater, which is fed into a high pressure hose, and that goes from one pump to the next and ultimately on shore to feed the Pelton motor and run the generator. We would typically, when we're fully scaled up, deploy perhaps 15 of these individual pumps in an array, and that would generate, in your average wave conditions, the ones I mentioned, on the order of 260 kW rated capacity. And that would, I'd have to check the number of homes that serves, but it's probably something in order of 500 or 500 homes. I'd have to look up that number. And so multiple arrays, very scalable, could be deployed offshore of islands or remote coastal regions to get them off of diesel electricity. And the technology is nearing getting close to commercially ready to deploy. This particular test will be our first extended operation in the ocean of a pump. From this, we will then add additional pumps, go from 1 to 3 to 5. That would give us a string of 5, and then we would add adjacent strings of 5 to get up to the full array of 15. And bring that pressurized seawater on shore. We have one other interesting idea that we will be incorporating, and that is pressurized seawater storage. So we would install a fairly large cylinder, cement tank basically, open at the bottom and top, so a big cement cylinder, drop that down to the seafloor, run our pressurized water into it, and we have a heavy movable cap on top of inside the cylinder, and so the pressurized seawater moves this heavy cap upward, and that maintains an equal amount of flow. So pump into the cylinder, the storage mechanism, and then out to the hose going to shore. And that would allow us to store anywhere from 1 to 5 days of wave energy to even out the times when there are lower waves and give basically a baseload capacity, baseload potential for a wave energy system. So that's the short story. In summary, it's a pressurized seawater system, bringing that seawater on shore. Each pump extends from the surface down about 100 feet deep. There are three main components: the buoy, the pump. I have not yet mentioned the variable sea anchor. It basically is a series of arms that rotate from horizontal to vertical on each wave, and so that helps to restore, that provides the thrust to resist the upward motion of the buoy on the wave upslope and then restores on the wave downslope. That's another unique feature that sets us apart from many of the others. We do not actually directly bolt each pump to the seafloor, but rather have what's called a slack mooring or a parabolic type shape mooring line. And so that makes the installation at lower cost compared to having to directly install each unit on the seafloor. So our main focus has been to keep the costs as low as possible. This industry, in my opinion, will be driven by economics, and we need to have wave energy come forward and be one of the lowest cost renewable energy sources. And I think certainly with our system, we believe we can compete very favorably against wind power, and certainly very favorably against solar. The waves are of course there all day, all night. The sun is not there all night. Winds come and go. The waves are more predictable, more regular. And with our undersea pressurized storage tank, we can even out any minor variations that might happen and provide that base load.